out there, lupus. We're not just going to talk about what it is, but how it works, the actual mechanics of how the body's own defense system can turn against it. Let's get right into it.
So, at its absolute heart, lupus, or SLE as it's officially known, is when things go terribly wrong. You know, the immune system is supposed to be your personal bodyguard, but with lupus, it gets confused. It completely loses the ability to tell the difference between a real threat and your own healthy cells. And that mistake kicks off a state of constant internal warfare.
So here's our game plan to really wrap our heads around this. We'll start with the attack itself. Then we'll look at the genetic blueprint that kind of sets the stage and what it takes to actually ignite the fire. After that, we'll unpack the vicious cycle that keeps the whole thing going.
Okay, so first things first. How on earth does a system that's built for protection end up becoming the biggest threat?
It really all boils down to a case of mistaken identity, but on a microscopic level. Just imagine your body's security team suddenly deciding that your own DNA, your own proteins, are dangerous intruders that need to be destroyed. That's the fundamental conflict that drives lupus.
So why? Why does this happen? Well, the first big clues are buried in our DNA. It turns out the potential for this internal war is often hardwired right into our genes.
And get this, the heritability is estimated to be as high as 60%. That's a huge number. It tells us that genetics aren't just some small factor here, they are a massive piece of the puzzle, basically setting the whole stage for the disease.
Okay, so what are these genes even doing? Well, they're kind of like mission control for three really critical jobs. First, they manage the body's alarm systems, these danger signals, like one called interferon. Second, they're in charge of how potential threats are identified and presented to the immune cells. And third, and this one is absolutely crucial, they handle the cleanup of everyday cellular trash. If any one of these jobs goes wrong, you've got the makings of a perfect storm.
And what's interesting is there are two different genetic paths to get there. The most common one is polygenic, which means lots of different genes each chip in a tiny little bit of risk. But in some rare cases, it's monogenic, where one single powerful mutation is enough to cause the disease, and it's often a much more severe version.
But here's the thing, and this is super important. For most people, just having the genes isn't enough. Something from the outside world has to come along and light the fuse.
Let's use a classic example. Researchers have also pointed to things like the Epstein-Barr virus, other infections, or exposure to things in the environment like silica dust or even cigarette smoke. Any of these can be that initial spark that sets the whole thing off.
But one spark doesn't really explain a chronic, lifelong disease, right? To get that, we have to understand the engine that keeps that fire burning. And that brings us to what's known as the vicious cycle.
Right. So how does that one little spark, that single moment of confusion, morph into a relentless fire that just won't go out?
The answer is a really powerful and kind of devastating feedback loop. It all starts with that failed cleanup job we mentioned. Dead cells and their DNA are left lying around. All this debris triggers a huge overload of those danger signals, especially interferon. That signal then wakes up B cells and tells them, hey, create weapons to attack our own DNA. These weapons are called autoantibodies. They go out, attack our tissues, and cause damage. And here's the kicker. That damage releases even more of the body's own material for the immune system to attack. The cycle just starts all over again.
And I'm not just being dramatic here. This is literally what immunological researchers call it, a vicious cycle. It's the core engine that powers the entire disease. So the most important thing to get here is that the disease learns to feed itself. After that first initial spark, it doesn't need another one. The damage from one attack literally becomes the fuel for the next attack. It's a self-perpetuating engine of inflammation.
So we get the mechanism now. We've got this out-of-control engine running inside the body. But what does that actually look like? What's the real-world cost? Well, that's the collateral damage. Because this attack is happening everywhere in the body, it's systemic. The damage can pop up almost anywhere. When those immune complexes get stuck in the kidneys, you get nephritis. When they attack the skin, you see rashes and lesions. In the blood vessels, it's called vasculitis. In the joints, you get arthritis. It could even impact the brain and nerves. The attack is widespread, so the damage is too.
You know, by breaking this whole process down, the genes, the triggers, and that vicious cycle at its core, we can start to see it for what it is. And that understanding is everything. It's the foundation for developing smarter treatments, and honestly, for having real empathy for anyone going through this fight.
So you see, lupus isn't just a random list of symptoms. There's a logical, if devastating, process behind it all. Thank you for taking a few minutes with us to really try and understand the mechanics of this incredibly complex internal battle.